Mid-rise timber construction is an extremely exciting new area of opportunity for building professionals. Major building companies in Australia have already tested and proven the construction benefits and savings of these rapidly constructed, structurally efficient and highly environmentally friendly and sustainable timber construction systems, and are keen to do more. The changes to the 2016 National Construction Code deemed to satisfy requirements will now open up these cost-effective building systems to the broader industry, a particularly exciting time. In this module, an overview will be provided of the major timber construction products and systems now available in Australia. This presentation will cover the building forms available, the efficiencies and cost benefits of timber construction systems, the different timber system options available, including general timber systems, both lightweight and heavy frames, massive wood panel systems, and also prefabricated and modular timber systems. With timber construction, there are many options. These include general framing such as lightweight frames, heavy timber post and beam, post-tension frames and portal frames, also massive wood systems, both massive panel walls and massive panel floors, and also modular systems, including fully finished volumetric timber construction. All of these options can be used with mid-rise timber buildings. Class 2 or 3 multi-residential type structures with many rooms, by their nature tend to be honeycomb type structures with many closely spaced walls and structural load paths, and accordingly there are a number of ways these can be constructed. For multi-rise apartments up to 6 stories, these are most economically done using lightweight timber framing, using conventional wall framing configurations in the upper walls, whilst in the lower walls, where there are higher structural loads, the wall stud members can be installed at more closely spaced centres, or larger stud members might be used. For multi-rise apartments from 6 to 8 stories, these can be a combination of both lightweight timber frames in the upper stories and massive timber construction in the lower stories. Apartments from 6 to 12 stories or higher can also be built fully out of massive timber construction. With apartments, a typical construction approach is to use a podium level, where the basement in the ground and the first level above ground, which is often retail tenancies, are constructed out of reinforced concrete. Above this, the floors can then be all timber, either general lightweight timber or massive timber or a combination of both. This approach using a podium raises the timber elements above the ground, thereby reducing any groundwater issues and providing a physical separation and barrier against termites if needed. For Class 5 office buildings, clients usually require a more open type floor plan, and therefore a different building form is generally used, which can incorporate wider space to heavy timber post and beam members or long span portal frame structures. There are many efficiencies and cost benefits in the overall construction phase of a building when using timber systems compared to traditional steel and concrete structures. This has already been tested and proven by a number of leading building development companies in Australia. Whilst generally building professionals often like to compare materials on a cost per square metre rate, this is not the real comparison that should be made with timber construction systems. The real benefit of the systems can be shown when the comparison is the cost of construction over the full construction period. By example, direct savings can be made from faster methods of construction, particularly when off-site prefabrication is used. Timber panels are also lighter and can be more easily manipulated and installed. The reduced weight of timber structures also means reduced foundation requirements. Timber buildings tend also to have a lot less occupational and health and safety issues. This is particularly the case with a shift to more off-site prefabricated solutions. There is also the ability for follow-on trades to commence much earlier in the construction process. They can effectively start fitting out the level below as soon as the floor system above is in place. No lost time due to backpropping or slab curing. This can dramatically reduce the overall construction time to completion. There is also significantly reduced on-site construction infrastructure and therefore preliminary costs due to the shorter construction periods. Items such as fixed cranes, site accommodation, storage areas, scaffolding and edge protection, hoists and so on. Sites also tend to have much better accessibility and far lower impact from noise and on-site activity on the local neighbourhoods, due particularly to the dramatically reduced amount of truck movements required. This provides a major benefit for suburban multi-residential development infill sites. In terms of costing comparisons, a number of costing case studies have been produced by Wood Solutions for office buildings, apartment buildings, aged care and industrial sheds. These are available from the woodsolutions.com.au website. There are also significant environmental and sustainability benefits using timber products. With a global awareness today of the impacts of climate change and rising atmospheric carbon dioxide levels, Using wood products from sustainably managed native and plantation forests provides a highly environmentally positive approach to CO2 reduction and storage. Wood, a product obtained from a natural resource that grows on solar energy, converting CO2 to carbon and emitting oxygen that we breathe, it is renewable, recyclable and biodegradable. Its production and processing are highly energy efficient, and its use is greenhouse positive. Sustainably managed wood products are arguably one of the most environmentally friendly materials available. So let's now look at the different types of timber construction systems available, starting off as the National Construction Code describes them with general timber systems, both lightweight and heavy timber systems. With lightweight timber systems, these are generally made up of conventional small section timber framing, which is then fire protected utilising fire-rated plasterboard linings. The most commonly used material is sawn timber, both F-graded hardwood and MGP-graded softwood. Typical thicknesses include 35 or 45 mm, and typical depths are 70, 90, 120, 140 and 190 mm. Treated timber framing is also available if required. Other engineered wood products include laminated veneer lumber, LVL, which is available in a number of thicknesses and a range of depths up to 1.2 metres. Lightweight engineered I-beams are also commonly used in floor joists or in roofs as roof purlin members. Prefabricated floor trusses are widely used as structurally effective floor joists in floor systems. The open webs also allow for easy installation and running of plumbing and electrical pipes and surfaces. Engineered prefabricated roof trusses are also commonly used. They are also highly structurally efficient and can be fabricated with few constraints on size of span. One project which provides an excellent example of general lightweight timber framing solution is the Green Project, built in Parkville in Melbourne by Fraser's Property, previously Australand. This 5-storey timber project utilised prefabricated timber floor cassettes and wall frames, which provided a particularly fast and efficient construction approach. The timber floor cassettes seen here were all prefabricated off-site and then craned into place. As well as a speedy solution, this approach also provided a much safer working environment for site staff. The builder has publicly reported that this timber construction system provided around 25% in construction savings compared to an alternative traditional reinforced concrete method. General timber systems can also include heavy frames. Typically, post and beam type construction utilises timber products such as laminated veneer lumber or glued laminated timber, often referred to as glulam. Glulam beams utilise small pieces of timber glued together to form larger elements with increased structural reliability. Typical depths range from 90 mm to up to 1 metre deep, and thicknesses range between 40 to 135 mm. Lengths of up to around 18 metres can be obtained, generally available in 300 mm increments. The only limit really to the size of a glued laminated timber member is transport, and as this photo clearly shows, very large timber glulam members can be manufactured if needed. Note the man standing on the top of this beam. Other engineered timber beams can include pre- or post-stress timber beams, using tension steel tendons to improve the structural performance of the members, or post-tension timber frames. These very ductile type structures are particularly useful in seismic zones, where the steel tendons used assist in resisting and absorbing the horizontally accelerated seismic forces. With most earthquake events, the building will remain standing, and these tendons can then be retensioned, providing again a structurally sound building. An exciting new engineered wood product approach globally uses massive engineered wood panel systems. These can be used for either floor, wall or roof systems. Massive panel construction includes laminated veneer lumber with a minimum 75 mm thickness, cross-laminated timber, or nail and glued laminated timber. Cross-laminated timber, or CLT as is commonly known, is a similar concept to plywood, but instead of using small thin veneers, CLT uses larger timber elements, with each layer laid and glued at 90 degrees to one another. CLT panel thicknesses are available between 50 to 500 mm, as cross-laminated timber in Australia at this point is all imported. The lengths and widths available tend to be sizes that can fit into shipping containers, so typically up to around 3 metres wide and up to 12 metres in length. An excellent example of a cross-laminated timber building is Lend-Lease's Forte Living Building in Docklands in Melbourne. This 10-storey timber building consists of 23 apartments and 4 townhouses. Whilst the ground retail area is reinforced concrete, all the upper levels are made of cross-laminated timber, including the lift shafts and fire stairs. As can be seen here, construction is very straightforward, with the timber panels quite simply connected using bearing connections held in place by small steel angle brackets and screws. This slide provides an overview of the site and some of the job statistics and allows the illustration of some of the particular benefits of this type of construction system over a reinforced concrete alternative. Firstly, the low impact of the site, particularly on the building's immediate neighbours, such as the occupied apartments seen at the top of the slide. In terms of workforce, the building system only needed 4 to 5 full-time workers on site. Construction also only required low-impact tools such as cordless drills. In this job, there were also no recorded OH&S incidents at all, which is a major consideration to building companies and workers. Also, extremely low impact in terms of truck movements, effectively only 1 truck movement per day, loaded with the panels needed for that day. The system is also very quick to construct, around 1/3 of the time of a concrete building. Also, as the timber is lightweight, around 1/5 of the weight of concrete, this can mean major savings with smaller foundations, and also only the need for a small remote-controlled crane. Also, environmentally, the building has a particularly low carbon footprint. The use of CLT in this building saved around 1,451 tonnes of carbon compared to a concrete building, a very significant saving. Timber systems today also include prefabricated and modular wood elements. These can include prefabricated cassette floor systems for the ground floor or the upper floor construction, as can be seen on these 2 photos on the left. Or they can be used in mid-rise timber apartment buildings such as the Green Project, shown in the photo on the right. Prefabricated cassette floor panel sizes are designed to fit in the back of a flatbed truck and are therefore typically around 3 metres wide and up to around 12 metres long. They provide very fast installation times and also dramatically reduce the fall from heights risk on building sites. So much safer for on-site workers. Timber concrete topped floor systems are also available. These systems utilise the timber and concrete acting compositely to improve the structural performance of the floor system, whilst the concrete topping also assists in providing additional acoustic and vibrational performance and control. Panelised timber wall elements are also available. These can be either partially enclosed with external cladding and windows installed off-site, or fully enclosed panelised systems where electrical and plumbing fittings are pre-fitted off-site. And the ultimate in off-site prefabrication, fully modular timber systems are also available, providing fully finished prefabricated volumetric modules that can simply be craned into place. So in summary, there are a wide range of timber construction options available for mid-rise timber construction, including general lightweight timber frame systems or heavy timber frame systems, massive wood panel systems, or prefabricated and modular wood systems. These all provide significant efficiency, speed and cost benefits when compared to alternative traditional systems, such as concrete and steel. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.